In this video, I will be explaining control flows, which build on Boolean operations and take them further to do things like multiplication, keeping things in memory, and conditionals. So starting off with a register, which is how you store memory in a computer basically. What you have the input, which is 1 or 0. Your data goes into an OR, as explained in the previous video, and then that passes its value to the AND. This is the right, so it allows you to write to memory if it's on. If it's off, you can't write to memory. That's just how it works. So you could switch it with a not, so you could say the default is it remembers, and here the default is it forgets unless there's active electricity going here. Anyhow, and then it loops, so it sends the data back to here, which means the data stays in memory until you rewrite it. And even if this value turns off, so we turn on a 1, sends a 1 through here, it's true if this is on, loops, but you keep a 1 in memory, and then if you want to change it to a 0, you have to disable the read-write and then re-enable it, and you'll have erased the memory, and so that, and then you can rewrite it with something else. Then you have the comparator here for equals, greater than, or less than, and what you do is you first pass the two values into a it would be a XNOR. That's what this is for. And that means that if your answers are 0, 0, or 1, 1, it's true, otherwise it's false. And that means that they're equal. If they're both 0 or they're both 1, they're equal. And then if B is 1, that means if they're not equal and B is 1, that means B is greater. So this is the greater output, and then if B is 0, then it's less, so this is the less output. So you equal, greater, less. 3 outputs, so and then you can do whatever you want with those. And then if you want to apply this to bigger numbers, but you'd have to do something like you apply this with an adder to add your pointer to go through the bigger number, and then you first check the biggest numeral, and then moving leftward until you find an unequal number, and then that's how you compare bigger numbers. Conditional. So here you have registers, and it's very similar to the comparator. And so basically, in this case, we're assuming something like the register has like 1. So if 1, then do something. If 0, something else. And so, but you could have it be 1, 0, and whatever the conditionals are. So the registers hold the conditionals, like what has to be true. And so if feed in the conditional, feed in the input. If the input is equal to the register value via XNOR, then it's true, and you do this logic here, and then it gets passed on to whatever you're going to do next. This is unrelated. If you're going to do an infinite loop, like a while instead of if, then you're going to just loop it back to right there again. And you're going to have some break which will pass it on. Anyhow, and then, so here, if it's false though, if the input's not equal to the register value, then you have, oh sorry, this is not quite accurate. I need to add a not here. So then you have a not there. And so if that value is not true, then you activate the connection to the transistor here to the next conditional, and so on and so forth until you either go through all the conditionals and nothing happens, or you get a conditional which does something. That's how you do conditionals. And then with an adder, the way you add numbers together is you're given an input value, and it's 1 or 0. And if your numbers are both 0, this is an XOR, then your answer is 0. If one of them is 1 and the other is 0, then it's true via XOR. And then you'll also have each of those inputs go down to an AND. So then if both are 1, the AND is true, and it passes a 1, which is a carry. So then you have 0 goes here to the first value, and you carry a 1 as your second then you have another fresh input with the carryover then you apply the same algorithm and so forth. It depends how many you want to have, or do you want an 8-bit or 64-bit or whatever you want, and you add. Shift, it's hardly even Boolean. It's just this is what it means. Like if you're going to multiply, like if you were going to multiply a binary number by 2, 1, 0, then you just shift. So it's very important to be able to do the shifting. So you just wire diagonally. So 1 goes here, 0 goes here, and you add a 0 here, and then hopefully you have a 0 on the side. If you don't, if you have a 1 here, you have overflow. An overflow is just when you're trying to pass a 1 and the register is full. Big problem. And so that's when you do a calculator, you get overflow error, things like that for big numbers. It's because of this issue. Then multiplier is built on these. So because I've explained how conditionals work and adders and shifters, I can just and I'm able to do this in English, but because it's abstract. But I've explained all concepts to go into this. So if, using a conditional, if 0 is true, then your logic here will be a shifter. And then if 1 is true, then, which would be, let's say, your second conditional, then you just copy the first. Okay, hopefully you have the right register space for that. Multiplication does require more register space than addition. And then, if it's also the first, so this is a double conditional, so you just use and so first, and also you have to go, if you did like added the point to the pointer, you check that there's nothing to the right, the register, that's the end of the register. And then if that's true, you copy, and I gotta add here, you do this, so you copy and shift if not first, so sorry about that, and shift, not first. Yeah, so basically if you're not dealing with the first, then you copy, if you're in it's 1, then you copy the numeral and you shift, and then you add them all together and with the adder, and voila, you have. And if you have more than one, you might need to do the adder several times, but this basically shows you how you can use, from Boolean, you can build basic logic and arithmetic. Conditionals, that's basically logic in a nutshell, and this is arithmetic, and you can extend these kind of methods to include things like division, square roots, exponents, sine, anything you name it. There's ways of doing it, but this, I think this is enough of an introduction, and then in the next video I will go building on these foundations, go into how these go together to build neural nets. Please like and subscribe if you like this content, and see you in the next video.